And welcome to lesson 7.3, day 1. Today we are going to talk about proving triangles similar to one another. So remember last semester we talked all about proving triangles congruent to each other. And if the triangles were not congruent by one of our 5 methods, we would just say they were not congruent. So for instance, we had an example A. When we mark those vertical angles congruent, that gives us 3 pieces of info to say that these 2 triangles are congruent by side, angle in the middle, side. The second one, notice each of these triangles have a side with a length of 4, a side with a length of 6, and then a side with a length of 7. So because it has 3 congruent sides, we would say those 2 triangles are congruent by side, side, side. Now, even though we are allowed in example C to mark that reflexive side congruent, notice the sides that are congruent in the first triangle and the second triangle are side, side, angle, not in the middle of the 2 of them. So this one would be not congruent because we talked about side, side, angle isn't enough info to prove triangles congruent. Well, this time we are going to change our focus to talking again about similar triangles. Remember, similar, we are just looking for the squiggle symbol there. And remember, in our similar figures, the angles are congruent, but the sides are proportional. So we keep the same shape, but our sides are going to be different to one another. Okay? And when we are determining if triangles are in fact similar, there are 3 methods. The first is called angle-angle similarity. So basically what we can say is if 2 angles of one triangle are congruent to 2 angles of another triangle, then that's enough information to say these triangles are similar. So in our first example, we have a 44-degree angle, a 70-degree angle. Since we have 2 pairs of angles congruent, these triangles are similar by angle-angle. Basically, angle-angle is enough in triangles because all of the triangles have to add up to be 180, we know those remaining angles would be the same. Our second method to prove if triangles are similar is side, side, side. Now this time, if all of the corresponding sides of one triangle are proportional to the sides of another triangle, then the triangles are similar. So essentially, we're looking to make sure the corresponding sides have the same scale factor. So 2/4 is our smallest side, and then we check out our medium-sized sides, so 3 and 6. And then we check out that last pair of sides, 4 and 8. Do they all reduce to be the same thing? The answer is yes. All of these reduce to be 1 and 2. So because all of those pairs of sides have the same scale factor, we could say these are similar by side, side, side. Last but not least, we have side-angle side similarity. So again, if 2 sides of a triangle are proportional to 2 sides of another triangle and their included angles are congruent, then the triangles are similar. So notice in this one we have those included angles marked congruent, and then 2/4. We're trying to check out, is that proportional to 4/8? Again, those both reduced to be 1/2. So yes, indeed, we are allowed to say that these triangles are similar to each other because of side, angle, side. So we have some examples to look through then on the next page. Looking at this first one, notice they're giving us information about angles. Now they show us right away that we have an angle that are both 69, and then we need to double check, okay, how big are those last remaining angles? Well, to get this angle here, if we take 180 minus 66 minus 69, this angle is going to end up equaling 45 degrees. And then because both of these are 45, we're able to say these triangles are similar by angle-angle. So this one is a yes by angle-angle. In the second example, if we look at our small to small, so 2/6, medium to medium, 4 over 8, and large to large, 5 over 9. Those do not reduce to be the same thing because 2 over 6 is 1 over 3, 4 over 8 is 1 over 2, 5 over 9. So none of these are equal to each other. So these are going to be not similar. On our next one, small to small, 3 over 9. Does that equal medium to medium? 5 over 15. And notice these vertical angles are congruent. So we're checking basically for angle side this time. Well, 3 over 9 is 1 over 3. 5 over 15 is also 1 over 3. So this one did work out because of angle side similarity. Next one, if we check these out, 6 and 9 are the two smallest. Then we have our mediums, 8 and 12. And then we have our larges, 10 and 15. And then all of these this time do in fact reduce to be 2 over 3. So we are lucky enough to say that these are similar by side similarity this time. Example 5 is a little bit interesting because notice they gave us parallel lines, not congruent sides. So what we know about these is, remember, the alternate interior angles are congruent. So we're able to say those angles are congruent. And then the vertical angles are also something we can mark congruent here. So even with just that information of the parallel lines, we are able to get two pairs of angles congruent. So those triangles would be similar by angle. And then last but not least, on this example here, notice we have side angle side similar to the beginning, but again, the angle's not in the middle, so we cannot say that these are similar to each other. All right, finally, we have two examples here at the bottom for you to try. Make sure you line up your corresponding sides to check for the first one. Don't forget about vertical angles. And then example B, also work to see are those similar by side. All right, the last page then, we have, again, a couple more examples to look at. Reminder, you can also write similarity statements when they are similar. So again, this first one, notice we kind of have a triangle within a triangle situation. Notice that they both have an angle that is 65. And then also notice that the small angle here, DEB, and the larger angle, ACB, both share angle B in the top. Okay, so by the reflexive property, both of those triangles are sharing angle B. So we're allowed to say that they are similar by angle similarity. And then again, the triangles that are similar, we have the big triangle, ACB, that's going to be similar to that smaller triangle on the inside, DEB. Again, lining up those corresponding sides and angles. On the second one, we have an example of 10 and 15. And then we want to check, how about 14 over 21? Will those both simplify to be 2 over 3? And then we're lucky that they have that angle in the middle congruent. So our method would in fact be side angle side this time. And again, lining these up, we would say that triangle TSU is similar to triangle PJM. Now, reminder, there is a difference when they're actually specifically asking you for the scale factor from our pre-image to our image. Remember, scale factor would be your image divided by your pre-image value. So again, take one of those pairs of corresponding sides, whether it be 21 over 14, or you could have said 15 over 10. But either way, that should reduce to be 3 over 2. So again, it doesn't really matter when you're checking, but when they specifically ask you for a scale factor, then that's when that order would matter. All right. Thanks everyone for watching. We will work more with these in class.